Hey guys, this is Bharani from Edureka, and I'm really excited to take this session on ggplot2. Let's look at the agenda. We'll start off by making some plots with the basic graphics, following which we'll understand what is grammar of graphics, and then finally we'll be making really beautiful graphs with the help of the ggplot2 package. So let's start. If your idea is to make quick and dirty plots, then you can definitely take the help of base graphics from R. And for the sake of the practical, we'll be using the iris dataset, and on the iris dataset, we'll be making a scatter plot, histogram, and box plot. So let's start the practical. This is our studio, guys. Let's quickly look at the iris dataset. This dataset comprises of 5 columns, which are sepal length, sepal width, petal width, and species. Now using the table function, let's look at the different species of iris flower. I can use the dollar symbol to select one particular column from a dataset. So what I'm doing is, with the help of dollar symbol, I'm selecting the species column of the iris dataset. So what we see is the species are equally distributed. That is, there are 50 observations each of setosa, versicolor, and virginica. So let's start with the plotting. We'll start off by making a scatter plot. The idea behind a scatter plot is bivariate analysis. That is, to understand how does one variable change with respect to another variable. And over here, we're trying to understand how does sepal length change with respect to petal length. We've given sepal length on the left side of the tilde symbol, and hence it will be plotted on the y-axis. We've given petal length on the right side of the tilde symbol, and hence it will be plotted on the x-axis. That is, whatever value we give on the left side of the tilde symbol, it is plotted onto the y-axis, and whatever value we give on the right side of the tilde symbol, it is plotted onto the x-axis. Let me zoom this. So we see that as the petal length increases, the sepal length also increases. That is, there is a linear relationship between these two variables. Let's make this plot more descriptive by adding labels. I've added 3 more attributes over here, which are ylab, xlab, and main. Now ylab can be used to give a label to the y-axis. Similarly, xlab can be used to give a label to the x-axis. Main can be used to give a title. So I've given petal length as the label for x-axis, sepal length as the label for y-axis, and the title is sepal length versus petal length, because that is what we're trying to determine. Let's also add color to this plot. I've added 2 more attributes, which are col and pch. Col can be used to add color. PCH determines the shape of this dot. So if you look at the previous plot, we see that this is a hollow circle without a color. Over here we see that this is a solid circle with a blue color. So when I give the value 16 to PCH, this will give me a solid circle. That was bivariate analysis with the help of a scatter plot. Let's do univariate analysis with the help of a histogram. The hist function can be used to make a histogram, and I'm plotting the sepal width onto the x-axis. We can see that the minimum value of sepal width is 2 centimeters, and the maximum value of sepal width is somewhere around 5 to 6 centimeters. And most of the observations, their value of sepal width is around 3 centimeters. Let's again modify the labels and add color to this. The labels used are xlab, main, and col. So I'm giving the label sepal width to the x-axis. The title is distribution of sepal width, and the color is aquamarine 3. You see this color over here? This color is aquamarine 3. We're done with scatter plot, we're done with histogram. Now it's time to make a box plot. We can use box plot to determine how does a continuous variable change with respect to a categorical variable. So over here, sepal length is a continuous variable, species is a categorical variable. And since I've plotted sepal length on the left side of the tilde symbol, it will come on the y-axis. And since I've given species on the right side of the tilde symbol, it will come on the x-axis. So this is sepal length versus species. And we see that if the species of the iris flower is virginica, then it will have the maximum sepal length. And if the species is of setosa, then it will have the lowest sepal length. Quite an interesting observation, isn't it? Again, we'll add labels, we'll also add color. So I've assigned the label species onto the x-axis. I've assigned the label sepal length onto the y-axis. I've also given it a title, which is sepal length of different species. So these were the plots made with the help of base graphics. Now there are two major issues with this. So the first issue is these are not of print quality. That is, if ever we would want to publish these plots for an international journal or an international presentation, then that would not be possible. Again, so another major issue is these are just images, and if you want to add layers over these images, again that is not possible with the help of base graphics. So that is where we need the help of ggplot2 package. And prior to making graphs with the ggplot2 package, we need to understand what is grammar of graphics. Because the prefix gg in ggplot2, it stands for grammar of graphics. So let us go to the presentation. We started off by making a scatter plot. We added a color to it. Then we made a histogram and a box plot. Then we understood what was the problem with base graphics. So it's finally time to learn grammar of graphics. So this is Sam. He's a data scientist and he'll teach us the grammar behind visualization. Now he gives this example. So there are two sentences, I am John and am John I. So Sam tells us that I am John is correct, and that is because it follows grammatical rules. And again, am John I doesn't make sense at all because it does not follow the grammatical rules. Now, since every form of communication needs to have grammar, since visualization is a form of communication as well, it needs to have a foundation of grammar. So let's look at the components of grammar. So we have data, aesthetics, geometry, and facet. Now prior to plotting, we need to select a data set. And this is the component data which we are talking about. So we'll select a data set. After selection of data set, we need to plot the data columns onto the aesthetics. So simply speaking, aesthetics are the scales onto which we plot our data. So we've selected the data, we've mapped the data onto the aesthetics. Now it's time to select a geometry. So the examples of geometry would be box plot, scatter plot, histogram, and so on. Now many a times what happens is we'll be working with huge data sets. And when we're working with huge data sets, there would be a lot of categorical variables and a lot of numerical variables. And plotting all of them onto a single graph might lead to chaos. That is why we need to facet our data. Or in simple terms, we need to divide the data into groups. And when we do this, this gives us better visualization. Now, these are not the only components of grammar of graphics. We have other components as well, such as the themes layer, coordinates layer, and scales layer. But broadly speaking, these are the major components. So let's start with the ggplot2 package. The ggplot2 package is a simplified implementation of grammar of graphics, which you've just understood. And this ggplot2 package has been written by Hadley Wickham for R. So this is what we'll be doing in the practical. We'll select the data and we'll map the data columns onto the aesthetics. And these are the aesthetics which we have x-axis, y-axis, fill, color, shape, and size. So for the aesthetics part, we'll be taking the iris dataset and we'll start off by mapping the petal length and sepal length onto the x and y aesthetic. Then we'll also take the species column and map this onto the color aesthetic. Next, instead of the color aesthetic, we'll be mapping the species column onto the shape aesthetic. So let's go ahead and do that. So ggplot2 guys, the main part of the session. We'll load the package. Now again, prior to loading any package, we're supposed to install it. So I click on install, I type out ggplot2 over here. And when I click on install, it'll be installed. But then again, since I've already installed the package, I don't need to do it again. So let's follow grammar of graphics. First step would be selection of data. And over here, the data is iris. Now this gives us a blank plot. We have selected the data. Now it's time to map the data columns onto the aesthetics. So I've mapped the sepal length onto the y aesthetic and I've mapped petal length onto the x aesthetic. You can see that over here. Petal length is on the x-axis, sepal length is on the y-axis. So let's select the geometry. Geometry is geom point over here. Geom point will give us a scatter plot. So these were the three components of grammar of graphics: data, aesthetics, and geometry. Now we already had done this with the help of the base graphics and we can easily see the difference. So this is a much better plot than what we did with the base graphics. Let's go ahead and play with the aesthetics of ggplot2. So there seems to be a problem in this. We are supposed to give ggplot over here. Now I've mapped. So already we had assigned petal length onto the x aesthetic and sepal length onto the y aesthetic. In this step, I've also mapped the species data column onto the color aesthetic. So what we see over here is the color is determined by the species column. And if the color is pink, then the species is setosa. If the color is green, then the species of the flower is versicolor. And if the color is blue, then the species of the flower is virginica. So what we can say is, if it is of virginica, then it will have the maximum petal length and sepal length. Similarly, if the species of the flower is setosa, it will have the lowest petal length and sepal length. Interesting observation again. Now instead of mapping the species column onto the color aesthetic, I am mapping the species column onto the shape aesthetic. So now the shape is determined by the species of the flower. So if the shape is circular, then the species is setosa. If the shape is triangular, then the species is versicolor. And if the shape is a square, then the species is virginica. Now let's see both of these plots. We can easily say that this plot, it is easier to draw inferences. And that is why it is always important to choose the right aesthetic for the right data. So finally, we'll go ahead and plot the species column onto both of these aesthetics, which are shape and color. So shape and color, both of them are determined by the species column. So we see that both of them have been changed. So this was playing with aesthetics. Now we'll also go ahead and look at multiple geometries. So we have histogram, bar plot, frequency polygon, box plot. So these are the different geometries which we have. So we'll be looking at each one of them. And to play with the geometry, I'll be using the houses dataset. Let's go ahead and load this dataset. I'll be using the read.csv function. So with the read.csv function, we can load a CSV file, and I'm storing the result in the house object. Let's look at the house object or the house dataset. So this column tells us the price of the house. This is the lot size. This column tells us if the house has waterfront or not. This tells us the age of the house, the land value of the house, whether the house is newly constructed or not. This column tells us if the house has centralized air conditioning or not. These are the fuel type and heat type used. Then we have the sewer system. Then we have the size of living area. Following which we have the number of fireplaces in the house, number of bathrooms in the house, and number of rooms in the house. Now we see that we need to remove this column. So these are just numberings for the rows. So let's go ahead and remove the first column. And to do that, I'll be using the deployer package. I can load the package with the help of library function. Again, prior to loading any package, I am supposed to install it. So I just type out deployer over here. When I click on install, the package will be installed. So it's time to delete the first column. This is the pipe operator from the migrator package, and this helps us to connect things. So from the house dataset, we are selecting all other columns except the first column. So you see the -1 over here. So that means we are selecting all other columns except the first column and storing the result again into the house dataset. Let's have a look at the house dataset. We see that the first column, which had the numberings of the rows, has been deleted. So it's time to play with the geometries. We'll start with a histogram. So the first step is to select the data. We've selected the houses data. The next is to map a data column onto the aesthetic. So we've mapped the price onto the X aesthetic. Then we've selected the histogram geometry. So we can understand that most of the houses, their price range is around 2 lakhs to 4 lakhs. And the maximum price of the house is somewhere around 8 lakhs. You see these values 2e plus 0.5, 4e plus 0.5, 6e plus 0.5. So they basically mean 2 into 10 power 5, 4 into 10 power 5 and 6 into 10 power 5. And that would again mean 2 lakhs, 4 lakhs and 6 lakhs. Let's add some color to this histogram. Prior to that, so you see this warning over here. Now this tells us that number of bins is 30. That is the default value of number of bins. So what I've done is I've increased the number of bins to see greater variation. This was the previous plot. This is the next plot with number of bins is equal to 50. So we see that there is greater variation in the distribution of price. We'll add color now. So I'm using the fill attribute to add color, and the color given is pale green 4. Let's also add color to the boundary. So I'm using the COL attribute to give a color to the boundary. This plot looks really pretty, doesn't it? So in the above plots, I have used fill as an attribute. So now let's use fill as an aesthetic. So over here, I'm mapping air conditioning onto the fill aesthetic. So what we see is the color is determined by the air conditioning column. So if the house has centralized air conditioning, then the color of the bin would be blue. And if the house does not have centralized air conditioning, then the color of the bin will be pink. So what we can conclude from this is most of the houses do not have air conditioning. So if you see this price range around 2 lakhs to 3.75 lakhs, and there is a greater proportion of houses which do not have centralized air conditioning. So as the price increases from, let's say, 3.75 lakhs to 8 lakhs, the probability of the house having air conditioning increases. Now let's change the position. Now this gives us the count of the bins. This will give us the proportion. So I'm using position is equal to fill. So when I say position is equal to fill, this will give me the proportion instead of the count. So what we can say is as the price increases from here to here, there is a greater possibility of the house having air conditioning. So as the price increases from, let's say, around $50,000 to $4 lakh, so over here we see that the houses which are in the price range of 4 lakhs, there is a greater likelihood for them to have air conditioning. As the price of the house increases from 4 lakhs to 8 lakhs, the probability of the house having air conditioning increases even more. If you look at these two bins, so you can see that if the price of the house is closer to 8 lakhs, then the house will definitely have centralized air conditioning. So that was histogram. Now we'll go ahead and make bar plots. Now people mostly get confused where to use a bar plot and where to use a histogram. So simple rule is this. Whenever you want to see the distribution of a continuous variable, then you'll go with a histogram, and variable you need to see the distribution of a categorical variable, then you'll use a bar plot. Let's make a bar plot. So the first step, select data, map data column onto the aesthetic. So we've mapped waterfront, which is a categorical variable, and we've mapped this onto the X aesthetic. We've selected a geometry, which is geom bar. That will give us a bar plot. So we see that this gives us the distribution of whether the house has waterfront or not. Let's look at the data set. Now this tells us that there are around 1728 entries, or in other words, there are 1728 houses. And out of those 1728 houses, we can say that around 1600 houses will not have a waterfront. So this is the bar which tells us that the houses do not have a waterfront, and this is the bar which tells us that the houses have a waterfront. So there are very few houses which have a waterfront. Now let's go ahead and see. So we've mapped the air conditioning column onto the fill aesthetic. So the color is determined by whether the house has air conditioning or not. And we've given the position to be fill. So this gives us the proportion. So these two, so this is the bar which tells us that the house does not have waterfront. And this is the bar which tells us that the house has waterfront. And if we take this bar, we see that if the house does not have a waterfront, then around 30% of the houses will have centralized air conditioning. And if the house has a waterfront, then around 25% of the houses will have centralized air conditioning. Now let's give another data column to the fill aesthetic. Now we are mapping the sewer data column or the type of sewer system onto the fill aesthetic. So this bar tells us that the house does not have a waterfront, and this bar tells us that the house has a waterfront. And if we look at this, so we see that if the house does not have a waterfront, there is a tiny bit of possibility that the house might not have a sewer system as well. And if the house has a waterfront, then the house will definitely have a sewer system, whether it is private or public. Another inference is if the house has a waterfront, then there is greater possibility for it to have a private sewer system. So if the house does not have a waterfront, then there is a greater probability that it will have a public sewer system. That was a bar plot. I've already made a histogram. So one alternative to a histogram can be a frequency polygon. A frequency polygon is again used to see the distribution of a continuous variable. So over here, I've selected the house dataset. I've mapped price onto the X aesthetic, and the geometry is geom_freq_poly. So the same inference can be drawn. We see that most of the houses, their price range is around 1.5 lakhs to 4.5 lakhs. Let's go ahead and increase the number of bins. So this gives greater variation. So this was the original plot. We increase the bin size. This gives us greater variation. Let's go ahead and again change the number of bins. Let's put it to be 100. So again, there is greater variation. Let's reduce the number of bins. So I say bins is equal to 10. Now there is the variation again decreases, and that decreases quite a bit. Now in this command, I've mapped the air conditioning data column onto the color aesthetic. So if the color of this curve is red, then this indicates all the observations of those houses which do not have air conditioning, and the color of the curve is blue. This indicates all those observations of those houses which have centralized air conditioning. So again, we can say that there are a greater number of houses which do not have centralized air conditioning. So that was a frequency polygon. Now we'll make box plots. Personally, box plot is my favorite. So as we know that with the help of box plot, we can understand how does a continuous variable change with respect to a categorical variable. So since price is a continuous variable, I've mapped it to the Y aesthetic and rooms. So initially rooms was actually a numerical variable. So this is actually a numerical variable, but with the help of the factor function, I am converting it to a categorical variable, and I've mapped it to the x-axis. So I'm trying to see how does price change with respect to the number of rooms. So we see that as the number of rooms increases, price of the house also increases. So let's look at this box plot and this box plot. So over here, the number of rooms in the house is 2, and its price will be somewhere around $1 lakh. And if the number of rooms is 12, then its price or average price would be somewhere around $3 lakh to $4 lakh. Now these dots which you see are outliers. So when I say outliers, that would mean they are beyond the average values. So these are values where the price of the house is closer to $8 lakh, but that is not the norm. So the norm of a house which has 12 rooms so would be somewhere around 3 lakhs to 4 lakhs. Let's go ahead and add color to this. So I've mapped the number of rooms onto the fill aesthetic. So that is why the color is determined by the number of rooms over here. Now I'm mapping the air conditioning column onto the fill aesthetic. So what we see is there are two box plots, so we can easily compare. So let's take this case. So when the house has 12 rooms, we see that if the house is centrally air conditioned, then its price will be much higher than the house which does not have centrally air conditioning. So the case is same for if the house has 11 rooms, 10 rooms, 9 rooms, and so on. So we can do multivariate analysis over here. So rooms, number of rooms is on the x-axis, price is on the y-axis. So we have two categories over here, which is determined by whether the house has air conditioning or not. So if we see at this, so we see that if the house has 2 rooms, there is no possibility of the house having centralized air conditioning. Let's make the next box plot. Over here we are assigning the sewer data column onto the fill aesthetic. Again, let's look at this and this. So we see that if the house has 2 rooms, then the house will have a private sewer system. Again, if the house will have 12 rooms, then it has two possibilities. So either the house will have a private sewer system or a public sewer system, and the price of the house which has a private sewer system will be higher. Now if we take a look at the house which has 11 rooms, then if the house has a public sewer system, then its price will be higher than the house which has a private sewer system. If we take a look at the house which has 9 rooms, then if the house does not have a sewer system, then its price will be lower. Now these two are quite comparable. So whether the house has a private sewer system or a public sewer system, its price would be somewhere similar. That was box plot. Let's go ahead and make a smooth line. A smooth line is used to see how does one continuous variable change with respect to another continuous variable. So over here, I've mapped price onto the y-axis, I've mapped the size of living area onto the x-axis, and the geometry used is geom-smooth. So what we see is there is a linear relationship, that is, as the living area increases or the size of living area increases, the price of the house also increases. You see this gray area around this line? So that is the error. You can remove the error by stating SC is equal to false. Now I'm mapping the air conditioning data column onto the color aesthetic, and I've given SC is equal to F. That is, we are making the error to be false. Since the color is determined by whether the house has air conditioning or not, so this is the line which tells us about all the observations which have air conditioning, and this is the line which determines all those observations which do not have centralized air conditioning. And again, we can say that if the house has centralized air conditioning, its price will be higher. So if we see the price for this, it stops somewhere around 4.5 lakhs, and this price goes above 6 lakhs. Let's make the next plot. So now the color is determined by the heat data column. So we have three heating types: electric, hot air, and hot water. And so the green line, this is for hot air, and the blue line, this is for hot water. So we can see that if the heating type used in the house is of hot air, then the price of the house would be higher. And again, if the heating type used is hot water, then the price of the house would be quite low. Now this is quite an interesting plot. We've used two geometries over here, geom point and geom smooth. I've mapped price onto the y aesthetic, I've mapped living area onto the x aesthetic. Now over here what you see is I have given the attribute method is equal to lm. So that is, it gives me a linear model. So this geom point gives me a scatter plot between price and living area. Geom smooth gives me a linear model between the price and living area. So again, as the size of living area increases, the price of the house also increases, and that is verified by this linear model over here. Again, this linear model tells us that there is a linear relationship between the living area and the price of the house. Let's make a similar plot. So over here, I'm using another aesthetic, which is color, and I'm mapping the air conditioning data column onto the color aesthetic. Again, I'm using two geometries, geom point and geom smooth. So the scatter plot is given to us by geom point, and these linear models have been given to us by geom smooth. So the color is determined by whether the house has centralized air conditioning or not. So where these dots are of red color, that would be houses which do not have centralized air conditioning, and these dots which are of blue color, they determine the houses which have centralized air conditioning. Again, we can make a similar inference that if the house has centralized air conditioning, its price will be high. So that was geom smooth. So we've looked at different geometries. Now it's time to facet our data. Now we see that this plot is quite chaotic. So to reduce this chaos, we can facet the data into two groups. So let's go ahead and do that. You can see the difference between this plot and this plot. So now till here the command is the same. That is, we've mapped price onto the y-axis, we've mapped living area onto the x-axis, we've mapped air conditioning onto the color aesthetic, and we've used two geometries, geom point and geom smooth. Now here comes the facet layer. So over here what we see is we are faceting it on the basis of the air conditioning column. So we have two facets which determine. So the first facet tells us that all of these observations do not have centralized air conditioning, and the second facet tells us that all of these observations have centralized air conditioning. Now making inference from this plot is much easier than the previous plot. So we can easily say that if the house has centralized air conditioning, then its price will be higher. Let's go ahead with the next plot. So over here, price onto the y-axis, living area onto the x aesthetic. For the color, I've used a different data column. So the color is determined by the number of fireplaces in the house. Again, the geometries are geom point and geom smooth, and I've divided the data on the basis of the fireplaces column. So there is one facet for the houses with 0 fireplaces, another facet for houses with 1 fireplace, and similarly for 2 fireplaces, 3 fireplaces, and 4 fireplaces. So now if we look at these three facets, we see that as the living area increases, the price of the house also increases. So for the house with 0 fireplaces, 1 fireplaces and 2 fireplaces, as the living area increases, the price also increases. If you look at the density of these two dots, you see that there are greater number of observations or greater number of houses which have 1 fireplace. Again, similarly, following that, we have greater number of houses which have 0 fireplaces. Now, this is quite scarce, which would mean that there are very few houses which have 2 fireplaces. If you take a look at these two facets, they tell us that there are just 2 houses which have 3 fireplaces. Again, there are just 2 houses which have 4 fireplaces. Now in this plot, I'm changing the X aesthetic, that is, on the X axis, I'm mapping the age column. Rest of the geometries and rest of the aesthetics are same. So I'm trying to understand how does price vary with respect to the age of the house. And I see that if the age of the house increases, the price decreases. So that is, if the house is old, then its price would be likely lower, and if the house is new, then its price would be likely high. So again, if we look at these three columns, again they tell us that there are greater number of houses which have 1 and 2 fireplaces. Again these two, so there are very few houses which have 3 and 4 fireplaces. So we've learned how to do faceting. Now we learn how to make these plots really presentable with the help of the theme layer. So let's go ahead with the first plot. So we had already made this plot to understand how does price vary with respect to the number of rooms. Now let's make this more presentable with the help of theme layer. What we need to understand is all of these are objects. So they can be grouped together and stored in one object. So I'm storing the result in the object and naming it as obj1, and I can build further layers onto this object. So onto the obj1, I am adding another layer, and this layer is of labels. So in the labs function, I'm giving the title of the plot, I'm giving a label to the x-axis, and I'm giving a label to the legend over here. So the title given is price with respect to rooms, and the label given to the x-axis is rooms, and the label given for the legend over here, which is fill, is again rooms. Now let me store this into another object, obj2. On the top of obj2, I'm adding the theme layer. So theme layer helps us to give a theme to our plot. So you see this panel.background attribute over here. With the help of this attribute, we can add a background to the panel. So this is the panel, and these are the different functions which we can use. So we have functions such as element blank, element grob, element line, and element rect. Now if you want to change any rectangular space, then we'll be using the element rect function. If you want to change the text of something, we'll be using the element text. Similarly, if you want to change some grid lines or the outer boundaries, then we'll be using the element line function. So over here, since I wanted to modify the background, which is of the rectangular shape, so I'm using the element rect function, and inside the element rect function, I'm giving the background to be pale green 1. Again, let me store this into a new object. Let me name it obj3. So you would have understood by now that we can add as many layers as possible onto these objects. So this is the benefit of ggplot2. I'm adding another theme layer over the object 3, and this theme layer consists of the plot title. So this was the initial plot which we had, and to that plot I wanted to change the title. So, and since I wanted to change the title, I'm using the element text function, and in that element text function I'm using the head just attribute to center align the title. Initially the title was left aligned. Now I'm changing the title to be center aligned. Again, initially the title was not bold. I'm using the face attribute to make the title bold. Similarly, the color of the title was black. I'm giving it the color cadet blue using the color attribute. Let me store this in another object. I'll be naming it as obj4. Now, it's quite difficult to understand. So these values, so what do they exactly mean? 2e plus 05, 4e plus 05. Now we do know that these indicate the price of the house in dollars. Now, that would be easier to understand. So let's go ahead and modify the y labels. So I'm using the scale y continuous function. So you can understand by this, since price is a continuous variable and I've mapped it onto the y axis, So that is why I'm using the scale y continuous, and I wanted to change the labels. So I'm using the labels attribute and I'm giving the value to be dollar. So initially these were the values which have been changed to values of dollars. So now we see that the prices are in $2 lakh, $4 lakh, $6 lakh, and so on. We see that this plot is really presentable. We've made all the changes. We've given proper labels to the x-axis, y-axis, and also to the legend. We've made the title to be more colorful. We've also given a very pretty background color. So now this is of print quality, which can be published in any international journal. Let's take another plot and let's add theme to it. This was a plot which we had already built. We had faceted the data and we were trying to understand how does price vary with respect to the living area. So let me store this in the G1 object. And on top of the G1 object, I'm adding the theme layer and I'm assigning the background to the panel using the panel.background attribute. And again, since it is a rectangular, I'm using element rect function and the color given by me is lemon chiffon. So this color which you see, this is lemon chiffon. Initially, the background of the color was gray. I've changed it to lemon chiffon. Again, let me store this result in another object. I'll name the object to be G2. Let's add another theme layer over this. Now, I've given a background to the legend using the legend.background attribute. So in the previous plot, we saw that the legend did not have a background. Over here, we've given a background to the legend. Let's again store this result in a new object. I'll name it to be G3. And on top of G3, let's add another theme layer. Now we can assign a background to the panel as well as the plot. So this is the panel and behind this is the entire plot. So this page over which you see, so this is the entire plot. So now I'm assigning a color to the entire plot. So I can use the plot.background attribute. And for this, I'm using the element underscore rect function and the color given by me is light coral. So this color is light coral. This is done. Now we'll take one final plot and we'll add a theme layer to that final plot as well. This was the frequency polygon which we had built. You see the size attribute? With this we can change the size of these curves. So if I give it to be around 5, I will be getting really rough curves. Again, if I change the size to be around 0.5, I'll be getting quite thin curves. So for the purpose of this plot, I'll be giving the size to be 1 because this seems to be perfect for the plot. Now let me store the result in P1 object. Onto the P1 object, we'll be adding a theme layer. So in the theme layer, I'm adding a background to the panel using the element rect function and the color given to the background is peach puff. So this color is peach puff. Let's store this into a new object, P2. And on P2, let's build another layer. So this layer is of the labels. So I've given the title, which is frequency polygon for price. Let's again store this into a new object, which is P3. So this is the final theme layer. So onto the P3 object, we've made two changes. Using the theme layer, so over here, I'm changing the title of the plot. And again, I'm giving a background to the entire plot. So the title given is frequency polygon for price. So over here, I'm center aligning the title. So initially it was on the left side. Now using the head just is equal to 0.5, I'm center aligning the title. Afterwards, I'm giving a color to the background using the element rect function and the color given is aquamarine 4. So this color which you see for the entire plot, that is aquamarine 4. So we've taken 3 plots and we've made it more presentable using the themes layer. So let's recap what we did in the entire practical. We started off by making a scatter plot, histogram and box plot with the help of base graphics. Then we understood that these are not up to the mark. So then we took the help of ggplot2 and we played around a bit with the aesthetics of ggplot2. Finally, we took the houses dataset and in the houses dataset, we tried to explore the data with different geometries. We started with a histogram, then we understood where is a histogram used and where is a bar plot used. Following which we've also used the frequency polygon geometry. Now we understood that frequency polygon as an alternative for a histogram, and then we've made some really beautiful plots with the help of a box plot, following which we've made some plots with the help of a smooth line. And then we decided to facet our data. Now after we were done with all of this, now we use the themes layer to make our plots more presentable. We took three plots actually, and we've added themes layer onto all of those three plots and made them more presentable. So this was it for the session, guys. Hope you've liked it. Thank you.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!